Morning, students. Welcome to our video lecture. In the last lecture, students, in the last lecture, we had done the sums of cumulative frequency distribution. Today also, we are going to continue that type of sums. So, all of you please pay attention. Now, students, in the last lecture, students, we had done the sums of cumulative frequency distribution, and that only we are continuing, students. Exercise 2, section E. We are going to do, students, sum number 5 and sum number 6. Students, first of all, I am going to do the fifth sum. Obtain less than 10 and more than 10 cumulative frequency distribution from the following frequency distribution. Obtain less than 10 and more than 10 cumulative frequency distribution. Now, as all of you are aware, there are two types of cumulative frequency distribution. One is less than 10 and other is more than 10. And if the distribution is inclusive, we have to convert it into exclusive, students, by finding corresponding boundary points. So let us start. Section E, sum number 5. The given inclusive frequency distribution is as below. Now, students, I am noting down classes and corresponding Fi. 25 to 29, 30 to 34, 35 to 39, 40 to 44, 45 to 49, 50 to 54, 55 to 59. Corresponding frequencies are 3, 8, 10, 5, 15, 8, 1. Students, these are the corresponding frequencies, and total of frequencies is 50. Okay, I'm writing here total frequency is equal to 50. Now, students, as the distribution is inclusive, we have to find boundary points. Now check the logic. Upper limit of first class is 29, lower limit of second class is 30. This gap stands out to be 1. Half the gap is 0.5. So to find lower boundary point, subtract 0.5 from lower limit, and to find upper boundary point, add 0.5 to the upper limit. So the first boundary point, subtract 0.5. So 24.5, add 0.5. So 29.5, subtract 0.5, add 0.5, subtract 0.5. So 34.5, add 0.5. So 39.5, subtract 0.5. So 39.5, 44.5, subtract 0.5. So 44.5, 49.5, subtract 0.5. 49.5, 54.5, subtract 0.5. So 54.5 to 59.5. So, students, these are the corresponding boundary points. Now, students, as all of you know, that there are two types of cumulative frequency distribution. One is less than 10 and other is more than 10. Okay, students, first I am writing less than 10 cumulative frequency distribution. Less than 10 cumulative frequency distribution. Now students, as we know, in less than time, we take upper boundary points, and in more than time, we take lower boundary points. So recall the two columns which we have made, less than upper boundary point and corresponding cumulative frequency. So here we write less than upper boundary points, and the second column is corresponding cumulative frequencies. Now, students, in less than time, we take upper boundary points. So upper boundary point starts from 29.5. We have to start with the value before. So in short, I have to write all boundary points: 24.5, 29.5, 34.5, 39.5, 44.5, 49.5, 54.5, and 59.5. Recall students, try to understand this very perfectly. There are two types of cumulative frequency distribution. One is less than time, other is more than time. In less than time, we use upper boundary points. In more than time, we use lower boundary points. The corresponding two columns are less than upper boundary points and cumulative frequencies. In less than time, we start with 0 because there is no frequency. For less than 24.5, add the frequency of first class 0 plus 3. So 3. Add the frequency of next class 3 plus 8. 11. 11 plus 10. 21. 21 plus 5. 26. 26 plus 15. 41. 41 plus 8. 49. 49 plus 1. 50. So, in less than time, we start with 0 and we end with maximum. Now, the other distribution is more than type, more than type cumulative frequency distribution. Students, here the two columns which we have to make is more than or equal to lower boundary points. More than or equal to lower boundary points, and the second column is corresponding cumulative frequencies. So be very sure about this column. Now actually we have to start with lower boundary points. So I have to start with 24.5 and end at 54.5, but we take a value after. In short, we write all boundary points. So 24.5, 29.5, 34.5, 39.5, 44.5, 49.5, 54.5, the last is 59.5. Now all the frequencies are greater than or equal to 24.5, so we start with maximum. Go on reducing the frequency of 1 plus 50 minus 3, 47, 47 minus 8, then 39, 39 minus 10, 29, 29 minus 5, 24, 24 minus 15, 24 minus 15. Students, if I subtract 24 minus 15, so 9, 9 minus 8, so 1, and then 0. The last cumulative frequency is 0. So students, these are the corresponding cumulative frequencies. Remember this students, here inclusive frequency distribution. Whenever students we have an inclusive frequency distribution students, then compulsory we have to find students boundary points. So the corresponding boundary point students we have already found out. This is how students we do the sum. So I think all of you have understood. In less than that, we use upper boundary points, and the title of the column is less than upper boundary points. Equal to is generally included in more than type cumulative frequency distribution students. Equal to is generally included in more than type cumulative frequency distribution. Okay, students. Now we go for sum number 6. Section E. Let us do students sum number 6 of section E. Okay students, so let us read the question first. Then students, we have to prepare a cumulative frequency distribution. The following data refer to the daily absence of workers in factory during 30 days. Prepare an appropriate frequency distribution. In hand students, we have to obtain less than time cumulative frequency distribution. We have to obtain which type of cumulative frequency distribution? Only less than 10. But first students, we have to go for original frequency distribution. Section E. Sum number 6. Here, first of all, we will find XH and find XL. Students, the highest observation is 6 and the minimum is 0. So range R is equal to XH minus XL. 6 minus 0, and that is nothing but 6 days. Okay, fair. Now recall I have told you, whenever the range is less than or equal to 10, it is advisable to prepare a discrete frequency distribution. So here students, we will go for which type of distribution, and the answer is discrete. So I am giving here the title. Okay, let us write here discrete frequency distribution of data referring to daily absence of workers in a factory during a month, means 30 days. Students, title is must. Always remember, title is must whenever students we prepare a frequency distribution. So, discrete frequency distribution. The following data refer to the daily absence of workers in a factory during 30 days. Students, so the first column will be, you can say, absence, and the second column will be the number of workers. Students, the first column will be the days of absence, xi will be days of absence, and then we will go for tally marks, and F5 will be three columns which we have to make in the sum. And we are going to prepare a discrete frequency distribution 0, 1, 2, 3, 4, 5, 6. Okay, then we will take total. Okay, students, now tally marks I suppose all of you know. So let me directly write the frequencies 5, 7, 5, 6. 5, 7, 5, 6. I already prepared. Then 4 to 1. 4 to 1. Totals of tally marks we don't take. The total frequency is how much? 30. Now this much students I can leave as assignment for you. Easily students we can do the tally marks. Tally marks is not at all a problem. Now students we have to prepare less than type cumulative frequency distribution. So now I'm giving the next title, less than type cumulative frequency distribution. In that students, the two columns will be absence less than or equal to, you can say absence less than or equal to x. Absence x less than or equal to. Let us write here absence less than or equal to x, and in the cumulative frequency we write number of workers. These are our only two columns in the table. 0, 1, 2, 3, 4, 5, 6. Students, less than 0, less than or equal to, less than or equal to x, means less than or equal to 0, we have 5. Then 5 plus 7, 12, 12 plus 5, 17, 17 plus 6, 23 plus 4, 27 plus 2, 29, 1. So here, all of you know students, we don't start with the value before because that we don't have. So, less than or equal to 0 is 5, less than or equal to 1 is 5 plus 7, 12, less than or equal to 2 is 5 plus 7, 12 plus 5, 17, less than or equal to 3 will be 5 plus 12, 7, 12 plus 5, 17 plus 6, 23, less than or equal to 4 will be 27, less than or equal to 5 will be 29, and less than or equal to 6 will be 30 students. So now, I am very much sure students that you have perfectly understood the sums of cumulative frequency. So section F at present students we are not touching. I hope that all of you have perfectly understood. Now as we have started section E, we will complete question number 1 to 4 also of section E. Now students, I am starting the first sum of section E, which is a very, very easy sum students. I am starting the first sum of section E. So I hope by this time students, all of you are very, very perfect with the sums of cumulative frequency and its corresponding cumulative frequency distribution. I hope by this time all of you are very much clear. Okay, I am reading the first sum of section E. Number of mangoes received from different trees of mangoes in a farm during a season of 30 days is as under. Prepare a frequency distribution by taking class length 5. Okay students, our first target is to locate range. For range, we need to check the highest and lowest observation. So the highest observation is 128 and the lowest is 92. So I start with the first sum of section E. Here XH is 128, XL is 92. So range of the data is R is equal to XH minus XL, 128 minus 92, so 36 mangoes. The data is regarding number of mangoes. Prepare a frequency distribution by taking class length 5. Now class length is 5 and no instruction is given whether to go for inclusive or exclusive. So students, we should prefer inclusive because in exclusive there are chances of making mistake. In inclusive we don't have any chance to make mistake. So we are given class length is equal to 5. So number of classes is range divided by class length, 36 divided by 5. So approximately 7. It is not exactly 7 because 7 5s are 35. So approximately students, we can make 7 classes or even we can take more than 7. This C into K must be greater than or equal to R. Now see, if I take class length as 5 and classes number of classes as 7, then 7 into 5 35. 35 is not greater than 8. So students, instead of taking 7 classes, I will take how many classes? 8. Always this relation must be satisfied. If I take 7 classes, 7 into 5 is 35. 35 is not greater than or equal to R. That is why number of classes which I am going to take is 8. This is approximately 7 point something, say 7 5s are 35. Correct? So what will remain? 1 and 0. So approximately this is 7.2. So we will go for 8 classes. Now students, the first class which we should take must include 93 and the last class must include 128. So let us give the type inclusive frequency distribution of number of mangoes received from different trees of number of mangoes received from different trees in a farm during the season. During a season. Inclusive. So I can start with 90. My first class will be 90 to 94. Classes, telemarks, and then corresponding frequencies. Classes are number of mangoes. And frequency is the number of trees, of course. Because the data is number of mangoes received from different trees in a farm during a particular season. Now students, the first class limits are 90 to 94, 95 to 99, 100 to 104, 105 to 109, 110 to 114, 115 to 119, 120 to 124, and 125 to 159, 4, 5, 6, 7, 8 classes. Why I did not take 7th class? Because if I take 7th class, then 7 into 5, 35. 35 is not greater than or equal to 36. So this relation C into K greater than or equal to R must be always followed. Focus on this, students. So if I take class 10th as 5, classes as 8, 40 is definitely greater than 36. So this relation is satisfied. Now students, tally marks, you can easily do on your own. I have done beforehand. 2, 3, 6. The frequencies are 2, 3, 6. Then 1, 2, 3, 4. 4 times 4. 1, 2, 3, 4. And the last frequency is 3. So this total comes out to be 30 because it is given that is for, you can say, during the season of 30 days as number of days are 30. We have not written here, but title we have cut short. Even you can write during the season of 30 days. That is okay. Let us write during the season of 30 days. So this is, students, our table. Students, please forgive me. For me, it is very difficult to draw straight lines. But roughly, this is our table, students. That's all. You have to be very careful in putting the lines. That's all. Students, total and writing here and is equal to 30. So, students, cumulative frequency distribution is a very, very important topic. But at a time, we are simultaneously doing the sums of tally marks also and the sums of cumulative frequency distribution. One more lecture, we will need to complete section E, sum number 2, 3 and 4. And then again we will do the sums of cumulative frequency distribution, which are still pending in exercise 2.1. Okay, thank you students. We conclude here.